Hello. In this introduction video about encapsulation and validation, I'll deal with the problem that we've come across in the last version of DrawingApp 1.2. That of invalid data that can be assigned to the properties of a rectangle object. So the new version will be DrawingApp 1.3. To summarize a problem in the previous version, DrawingApp 1.2, we can pass invalid data to a rectangle object. With invalid data, I mean that currently any integer value can be assigned to the properties, whereas according to the program specifications, only a specific range of values should be accepted. And we see that in the output. So here are displayed all the values that we assigned, resulting in an area and perimeter that are both negative. So what is the solution? Well, first of all, encapsulate the instance data members x, y, height and width in the rectangle class. And second, we need to validate whatever data is trying to be assigned to a property of rectangle. Only when a validation passes the tests can that data be accepted. Looking at the DrawingApp specifications that we have stated in the Getting Started video. So far we have implemented the properties or instance member variables for the rectangle class in version 1.1. We added instance methods in version 1.2, and now in order to solve the invalid data problem we'll implement encapsulation and validation in DrawingApp 1.3. And the goal is to prevent any client to assign values to the properties that do not fall in the range of accepted values. So for x and y properties, only the values between 0 and 1000 included may be accepted. And for the height and width, only the values between 10 and 500. Encapsulation step 1. Set instance member variable to private. Well, the core of our current problem is that any client can directly access any property of rectangle. So step 1 is to make direct access impossible. How? And I'm going to demonstrate that with the height property first. Well, by setting instance members to private. So we change the access modifier from public to private. This results in the app not being able to assign any value to the property anymore. The assignment will result in a compiler error because height has private access. For your information, access level modifiers in Java are public, private, protected and default. We'll see that during inheritance. So blocking direct access is okay, but then the client has no access whatsoever to the height property. And that's not very interesting. So how do we provide access then? Well, we do that in encapsulation step 2. We provide a public setter, also known as a mutator method. Just a method with one parameter via which the client passes the value he wants to be assigned to the height property. And in the setter, we assign the value of the parameter to the property of the object. So this.height is height. So the setter is a method with one parameter of type, same type as the type of the property we want to assign a value to, and no return type specification, so void. The app will now invoke that method and pass the value as argument. Will that solve the problem? We'll see that in the printout. Well, no, the value is still accepted. So this approach doesn't create any compiler nor runtime error, but we still have a problem. The invalid data is still accepted. So how do we solve this? Well, since a setter is just a method in which we provide some logic, well, let's extend the amount of logic that we implement the setter with. How? Validation logic. Before assigning the parameter to the property, we test the value. So if height bigger than some minimum height, which I here define as a constant with a value of 10, and if height is less than a maximum height of 500, I perform the assignment. Else we need to notify the clients, and we're using the print for now. This might seem a bit strange because in the previous version I demonstrated that printing to a console is a bad practice. I repeat that it is a bad practice to print to the console in the library class, and actually the way to deal with it is to replace by exception handling, which will be implemented in a later module, because Printing to the console is useless if our app is a graphical user interface or mobile app. They don't have a console, so the message that we print out here will not become visible. But since we are using, for now, a console application, are we going to use this approach? It's a temporary approach. Remember that. Encapsulation step 3. What if a client just wants to read out the value of the height property? Right now, it can't, since its access level is private and our setter doesn't return anything. How then? Well, by adding another public method whose sole purpose is just to return the value of the height property. And we call that method a getter, also known as a accessor method. So the getter is public. It returns something of type, well, which is the type of the property, int height, so int get height, no parameters, and it just returns the value of the property. How can the client use this? Well, rect1.getHeight, the return value is assigned to a local variable which can then be printed out. This results in the current beta version. Beta because I've implemented encapsulation and validation only with the height property. But having a look at where we are so far, so if we execute setHeight and we pass an invalid value, we get a notification in the console. Invalid height -100, and with a message that informs the user what the minimum and maximum values are, so that he knows why he gets an invalid height notification and what values he should pass in order to prevent that error notification. If we pass a value that falls within the accepted range, then the property will receive the value of 100. And if we print out the message of the rectangle, we see that the height now has an acceptable value. And for the get, if we ask for the height, we can print out the message rectangle has a height of 100. So that's for encapsulation and validation for the height property. If we would implement it for the remaining properties, our UML class diagram would look like this. So the access modifiers of all the properties are set to private. It's a minus sign in UML. And for each property do we provide a getter and a setter. Get set x, get set y, get set height for width. And I have an additional set position method I'm going to demonstrate you in a second. And the remaining methods is what we saw in a previous version. ToString, get array, get perimeter. So here I display the implementation in Java. So all properties set to private and the getters and the setters. That is what I'll demonstrate in the hands-on video. Get set for y, get set for height, get set for width. And the set position allows the client to pass x and y directly. And here are the 3 dots for the remaining methods. DrawingApp 1.3. So if we would invoke the setters as such and print out the state of the rectangle object, we get the output rectangle x10, y20, height 100 and width 200. Then for the getter is what we saw earlier. And for the area and perimeter, then we get positive values. Let's implement all this in the next video, the hands-on session for version 1.3. So what I'm going to demonstrate is first of all, add in the lib package, the package demo03 encapsulation validation, and implement the discussed topics in the rectangle class. And in the app package, add package demo03 encapsulation validation as well, and use the new topics of the rectangle class in a new version of the DrawingApp. See you in the hands-on video. Bye bye.